So this experiment is for refraction index. And what is refraction index is basically, normally if you have the light, when it goes through air, it has the speed of light that is 3.0 times 10 to the 8 meter per second. But as it goes through a substance, such as a liquid, what happens is, as it bumps into these molecules, it slows down. So the speed of light in air is different from the speed of light through a liquid. And a refraction index is the ratio of these two. So it's going to give you the speed of light in air divided by the speed of light as it goes through a liquid. And of course, since substances have different structure, different density, they're not attached the same way to each other. If they're really compact and dense, the light will keep bouncing into too many molecules and it will slow down a lot. But if it goes through a much lighter substance that is not dense, it will go through it faster, and that of course will slow down, but not as much as going through a dense material. So in a way, the refraction index is kind of correlated to density, but it's a very quick and simple and clean method to identify substances. So each substance will have slightly different refraction index, so you can run few knowns, like we did, for example, for the TLC or the melting point. You kind of measure the melting point for a known and you compare your unknown to the known. We're going to do exactly the same thing here. So we have known liquids that you're going to run and see their refraction index, and then you get an unknown and you're going to also measure its refraction index and correlate and identify your unknown both based on the refraction index. Now, how do we use this machine? So you have here this cap or pug. It looks like more of a hockey pug. And what you do is, this is just a cover. The whole process happens in this little hole. It's a little container here where you need to put your liquid. And there is a prism. When you look closely, you'll see there's a little opening there. So that's where the light is sent through your liquid. So, first of all, make sure you have a clean surface. So how do we clean it? We usually use a few drops of isopropanol and then use Kim wipes. Why Kim wipes? This is a paper that doesn't scratch the surface, because the whole measurement is based on how smooth that glass surface is, because if you scratch it, you're going to have distorted results. So we're going to clean it very well with some isopropanol. And the good thing about isopropanol and the fume hood, that it evaporates quickly. So you don't have to wait too long to make sure that it's clean. Once your surface is clean, you have to fill this little hole with your liquid. And we're going to start with water. And you have to fill it all the way to the rim. And you can see, even if the procedure says put 20 drops, I would just go all the way and fill it to the rim, and then you cover it. So you see here, that's how much you want to fill it up with water. You really want to go to the brim completely filled. And then you cover it with the pug. I call it a pug. And then there is here on the top, all you have to do is wait and read. You don't have to do anything, and it tells you there Ri for refraction index and the temperature. So one thing very important about refraction index, it really is correlated to the temperature, because if the temperature is high, the molecules move away from each other, so you're going to have a different type of refraction index as when they are like cold. So for water here, it reads 1.3329. All we have to do is compare it to the real value, which is the literature there. It says it should be 1.3330. So it's very close to So when we put the water, it was reading 1.3328 or 29, but the normal refraction index for water is 1.330. So what you do, if it's not exactly 1.330, you have to calibrate it. And the way you calibrate it, all you have to do is push on the on button twice. Once you push on the on button twice, it will take a few seconds and then it will read the correct refraction index. Now our machine is ready because we calibrated it with water and it's reading what we want it to read. So what do we do next? We're going to go to our first known. So how do you do it? First of all, you remove all the water from the little hole here, and I'm going to clean it, make sure it's completely dry, and go gentle when you touch that surface, but I want to make sure it's clean and dry. Once it's clean and dry, all you have to do is fill it up with your liquid. So here, like I did for water, I need to completely fill this hole to the brim. That means, and I saw it before, if you don't completely fill it, you might have very bad reading. And you cover, and you wait for a few seconds, and you just read. That's all it takes. So you can see here, for this liquid, for ethyl acetate, it's 1.3723 at 20 degrees Celsius. And that's what you record. You record the refraction index and the temperature. When you're done with your known, you want to go to the next unknown. So what we like to do is make sure you wipe it dry. And then you can clean with some isopropanol. And just go to the next substance. And you repeat the same. So there's no recalibration. If you calibrate it once, it's good enough. Now, after you do this, you fill it, you read, you fill it, you read with all your knowns, and then you're ready now for your unknown. Same thing. First of all, dry. You have to clean this container, the hole there, and then you're going to put your unknown in there. Your unknown has to be liquid, of course. And don't forget to write your unknown number. We always have to write the unknown number. And then you fill it up to the brim. Okay? Then you cover and you read. So here we go. Our unknown is 3.960. It's different, so I don't think it's ethyl acetate. But as you run all your knowns, you should be able to identify your unknown. And when you're done, again, you empty this hole from your liquid with O-Chem wipes. You rinse it with isopropanol. And then once it's rinsed and clean and dry, you leave it for the next person to start all over again. And thank you.